Hi students, I am Professor Ravesh Ahmed Hussaini, working as Assistant Professor in Mechanical Engineering Department at Sharad Institute of Technology, College of Engineering, Yadra. In previous video, we discussed some fundamental parts related with the steam turbine, as well as we discussed points regarding that impulse turbine along with their construction, working. Similarly, we also discussed the construction and working of reaction turbine along with their differences. Now in this video we will discuss that compounding of a steam turbine. So students, in case of the large capacity power plant, the pressure generation capacity is more than 40 bar, and in case of the NTPC power plant, that is National Thermal Power Corporation, they generate more than 100 bar pressure. Okay, so in this particular case, compounding is most mandatory term. So compounding is done to reduce the rotational speed of the impulse turbine to practical limits. So the situation, you just take example, suppose the steam pressure is more than 200 bar. So it strike on the when it strike on the surface of the blade, and after that blade absorb that particular kinetic energy, and when they can start rotating, the speed of that turbine is near about more than 2000 rpm. So this is a very important thing to reduce that rotor speed in order to protect it from the mechanical damage. So that's why that compounding is done. So the compounding is done to reduce the rotational speed of the impulse turbine to practical limits, and definitely it can be done for multi-stage turbine, not for single stage turbine, and it can be used only for large capacity power plants. So compounding is achieved using more than one set of the nozzle, more than one set of the blades, more than one set of the rotors in the series. So either the steam pressure or jet velocity is absorbed by the turbine in stage. So the compounding is the method to reduce the rotational speed of the turbine by either reducing the pressure or by reducing the velocity of the steam through n number of the sets like nozzles, blades and rotors, that is like moving blades. And that compounding can be done by using three basic methods. The first is pressure compounding. Here pressure is reduced and we can maintain that particular rotational speed at a constant level by reducing the pressure. In second case, velocity compounding. Here we reduce the velocity and we can reduce the rotational speed. And in case of the third stage, we are reducing both, that is pressure as well as velocity. So let us discuss with that first point, that velocity compounding. So keep in mind that the name indicates that velocity compounding, here the shaft speed, that is blade speed, is reduced by reducing the velocity only, not by pressure. So here there is one special arrangement. The first important is that nozzle, then moving blade, then fixed blade, then moving blade. So such kind of the arrangement is there in case of the velocity compounding, that moving blade and fixed blade, they are arranged in series alternately, one after other. So here that velocity compounding is done for reducing the rotor speed by reducing the velocity parameter. So as far as that working is to be considered, whatever the steam is generated in the steam boiler, it enters in the steam nozzle. In steam nozzle, that pressure energy get converted into kinetic energy. Here you will get idea, its velocity is increases, the velocity of the steam is increases when the steam is come in contact or when it is passing through the nozzle. Simultaneously the pressure is decreases. Here you will get idea about the reduction in the pressure in the nozzle by increasing the velocity, that is kinetic energy. and that high kinetic energy steam, that is high velocity steam, is further enters on the first set of the moving blade, where in first set of the moving blade, that blades absorb that particular kinetic energy and they can start rotating, and here you will get idea that particular velocity is reduces. Similar way, the same steam is passed through the fixed blade, where that velocity is remains constant. There is no any change of that velocity when that particular steam after leaving from the moving blade when come in contact with the fixed blade. So the pressure is or that particular velocity remains constant here. Further, when the same steam after that fixed blade when enters on the second stage of the moving blade, again you will get idea about that velocity goes on reduces by absorbing the energy by that blade and they get start rotating. In this way, n number of the arrangements are there of that fixed blade and moving blade in series manner, one after other. So in this way we can reduce the rotor speed by reducing the velocity. So this is all about velocity compounding. So this is the explanation. Here there are total 2 sets of the moving blades are used in order to reduce the velocity. Generally more than 2 or up to 6 to 7 stages is there in case of the large capacity power plant in order to reduce the velocity. The main motto of this velocity compounding is to reduce the rotor speed by reducing the velocity parameter. So now these are the advantages of the velocity compounding. The arrangement has less number of the stages. Definitely in that previous slide you will get there are only 2 stages are there, hence less initial cost is there. So it is implemented mostly in medium capacity power plant. The arrangement requires less space, less number of space. Definitely the space required for that particular component is also less. The system is reliable and easy to operate. The fall of the pressure in the nozzle is considerable, so the turbine itself need not work in the high pressure surroundings and the turbine housing need not very strong. So these are the advantages of that particular velocity compounding. Disadvantages: more friction losses due to very high velocity in the nozzle, because the nozzle is a device where we will get the high kinetic energy of the steam, so the friction losses is high. Second one, that less efficiency because the ratio of the blade velocity to the steam velocity is not optimum. And third one is the power developed in the latter rows is only fraction of the first row. Still all stages require same space, material and cost. So these are the some disadvantages of the velocity compounding. Now second most important method of reducing the rotor speed is pressure compounding, where the rotor speed is reduced by reducing the pressure parameter rather than velocity parameter. So here arrangement is first set of the nozzle, then first set of the blade, again second set of the nozzle, second set of the blades. So students, here we will get idea about the alternate arrangement of these rows. First set of the nozzle, then again first set of the blade, second set of the nozzle and second set of the blade. That steam is continuously passing through these all alternative stage, and at the end we will get the less pressure, and because of that the rotor speed is reduced by reducing the pressure at the end of the stage. So here whatever the steam is removing from the boiler is enters in the nozzle. In nozzle the pressure energy is decreases. Here this line indicates the pressure energy. So here the pressure energy is decreases. Further, that pressure energy, that less pressure energy of that particular steam is enters on the moving blade. The part of the blade get absorb that energy and the velocity is reduces here, and no doubt the pressure is remains constant. Further, that pressure drop takes place when the same steam from the first stage of the blade is passing to the second stage of the nozzle, where you will get the idea about the pressure is decreases. again in moving blade that pressure is remains constant. So in this way, with the help of more than 2 or up to 5 to 6 stages or rows of this alternate arrangement, we will get reduction of the rotor speed by reducing the parameter like pressure. So here once again I that repeat, whatever the steam is removing from the boiler, first it enters in the nozzle. In nozzle the pressure is decreases by increasing the velocity. Then further that pressure is remains constant when that steam from the first stage of the nozzle is come in contact with the first stage of the blade, where pressure remains constant. And after the steam is leaving from the first stage of the moving blade, and when it come in contact with the second stage of the nozzle, where in nozzle again velocity is increases and pressure is decreases. Here you will get changes of the pressure. Here in first stage the reduction in pressure takes place, and again further the pressure is reducing in the second stage of the nozzle. So in this way, by alternate arrangement of that nozzle and blade, the pressure is continuously reduced, and we will get at the end reduction in the rotor speed. So this is the explanation of that particular pressure compounding. Now the next important is that combination of both, that is pressure as well as velocity compounding. So students, here you will get idea. Here we are just get the combination of that pressure as well as velocity compounding. So here this is the first stage and this is the second stage. Here we consider the two-stage condition for reducing the pressure as well as velocity. So in first set there is only one nozzle, one moving blade, fixed blade, again second moving blade. So in first stage there are total 2 moving blade, 1 nozzle and 1 fixed blade. Similar way, the same components or same arrangement in the second stage, 1 nozzle, 1 fixed blade and 2 moving blade. So here we can reduce the rotor speed by both reduction in pressure as well as velocity. So students, here you will get idea about the construction as well as working. So initial condition, whatever the steam is removing from the boiler is first come in contact with the first stage of the nozzle, where the pressure energy goes on continuously decreases by expansion process and the velocity is increases. Initially we will discuss that only velocity factor, and afterwards we will discuss that pressure factor. So when the high pressurized steam from the boiler when enters in the nozzle, the velocity is increases. Here you will get that dotted lines. Here that velocity line is represented by the dotted lines. Here you will get idea. The velocity is increases in the nozzle area, nozzle section. Further that velocity get particular of steam get absorbed by the moving blade, and velocity reduction takes place by that dotted line. Here you will get idea about that reduction in the velocity, and that velocity of that steam is remains constant when the same steam is enters on the first stage of the fixed blade. Here you will get idea about velocity remains constant. Further, the same steam from the fixed blade when entering to the second set of the moving blade, here you will get idea about the reduction in the velocity because of the absorption of the energy by that blade. And further, when the same steam after first stages when enters in the nozzle, again that velocity increases in the second stage. Here our purpose of that first stage is completed, while in second stage again increasing the velocity. Further that velocity decreases in the second stage when that steam is come in contact with the moving blade. That velocity remains constant when the steam is come in contact with the fixed blade, and afterwards in case of the moving blade, when again it come in contact, then again velocity goes and reduces. So in this way, at the end of the each stage we will get the low velocity. It can be denoted by the dotted line. So in this way we can reduce the rotor speed by reducing the velocity parameter. Similar way, we can reduce the rotor speed by reducing the pressure parameter in pressure velocity compounding method. So whatever the steam is removing or coming from the boiler when it enters in the nozzle, the pressure is decreases. Here you will get idea about that line. You will get idea that pressure is decreases when that steam is coming in contact with nozzle. Further, that particular pressure is remains constant when it is passes through the moving blade as well as fixed blade. Similar way, again from the first stage, that steam is come in contact with the second set of the nozzle, where again pressure drop takes place. Here you will get idea in first stage the pressure drop and second stage pressure drop. Here in second stage you will get the reduction in the pressure drop as compared with the initial stage, and again the pressure is remains constant throughout in moving as well as fixed blade. So this is all about pressure and velocity compounding. So in simply way, in case of the compounding, the main purpose is to reduce the rotor speed, because in case of the large capacity power plant, whatever the boiler pressure is there, when it totally strike on the surface of the turbines, the turbine shaft rotate more than 1000 rpm. So it is very difficult as far as that maintenance point of view, when that particular shaft or that blades are rotating at a larger speed as compared with the required amount. So it become damage to the bearing as well as the assembly. In order to avoid that, the speed of the rotor must be reduced or must be controlled by that controlling method like compounding. So in this video we discussed total 3 concept of the reducing the rotor speed. In first method, that is velocity compounding, second is pressure compounding, and third one is pressure velocity compounding. In velocity compounding, velocity, the parameter is reduces continuously when it is passing through the n number of the sets of the elements like moving blade, nozzle and fixed blade. Similar way, in case of the pressure compounding, the pressure is continuously reduces when it is passing, when the steam is passing through the elements like nozzle, fixed and moving blade. Similar way, in case of the pressure velocity compounding, the rotor speed is reduces by reducing the both parameters simultaneously through passing through the n number of the elements like nozzle, fixed blade and moving blades. Thank you.